You awake in a barren island. The only goal is escape, but with just your own strength, it is impossible. The mountains are too steep to surpass, and the land too desolate to do anything but die. The only shining hope is a basic message carved within the rocks. Before you set sail, go out to sea. To understand the message, we need to delve into the world of paradoxes. We will define what they generally are, cover the three main types with examples, show how the examples break down upon closer inspection, and end on why no paradox exists. Paradoxes have different requirements and characteristics depending on the field or scenario. This can quickly spiral into extremely niche definitions. For the sake of this video, we will define them as a series of statements that contain a blend of true and false assumptions that are directly intertwined with one another. The first type that we will be covering are veridical paradoxes. They are situations with true conclusions even though they have an air of absurdity. The most famous example of a veridical problem involves a theoretical man who is 20 years old but has had only 5 birthdays. Since his birthday is on a leap day, it only occurs once every 4 years. Although the situation is technically true, this statement is fairly nonsensical. The next major type is called falsidical paradoxes. These have the exact opposite definitions of veridical paradoxes. They are situations that have false conclusions even with seemingly correct logic. An example of a falsidical paradox is the idea of an arrow being fired at a target. The exercise assumes that for the arrow to reach the target, it will have to travel half the distance to get there. Each time the arrow finishes traversing half the remaining distance to the target, it must then travel half of the new remaining distance. This continues down all the way to infinitesimal measurements. This would lead to the conclusion that, since the arrow must always travel half the distance, it would never actually reach the target, which is an obviously false conclusion. The last and most varied type of paradoxes are antinomy paradoxes. They are contradictions between a set of reasonable conditions where both of the conditions seem equally justified. The most straightforward example is the statement, "This sentence is false." If you say the statement is true, then it would be false. But if you say the statement is false, then it would be true. Following either of the possibilities leads to a major contradiction. Every man-made calendar known to human existence is flawed in one way or another. The only thing we are capable of changing is how the calendar is flawed. The Gregorian calendar is flawed due to a full rotation of the Earth equating to a 365.24 day year. This gets worse given the fact that Earth's rotation technically has 23 hours, 56 minutes, and 4 seconds in a day. With a graph, you can easily see how these minuscule discrepancies would add up over time, eventually equating to the calendar being off by around 24 days after 100 years. This left humanity in a bind. Instead of trying to create a completely new time system, they decided to just add leap years to balance out the inaccuracy, giving birth to the elusive February 29th. But this change does not only apply to February 29th. Regardless of what the calendar dictates, your birthday will always pass after the 365.24 days, and will only be on the correct day once every 4 years. The true path of a fired arrow is revealed with a simple application of derivatives. We normally figure out rates using a change in the y-axis over a corresponding change in the x-axis. Change happens over time, so it should be impossible to figure out change in a single point, but derivatives demonstrate how you can overcome this obstacle. Instead of using a concrete number, we use the conceptual idea of a small difference shrinking towards zero. The derivative never has a real number applied to it and never reaches zero. But as the derivative gets more insignificant, the rate of change within a single point becomes more apparent. You can apply the same idea to the arrow's path. The arrow continually crosses smaller halfway distances, going from point A to point B. Without resistance, the arrow would keep traveling endlessly and would never reach an end. So we will simply put an obstacle slightly before point B, at one of the endless halfway points. Instead of having a definitive endpoint when an archer fires, there is always a conceptual idea of where the arrow can go. It will continue to inch forward, never reaching what lays beyond the obstacle. It forever remains stuck halfway between where it lies and where it could have gone. The sentence paradox quickly crumbles when you ponder what part of it could possibly be false or true. Believing a sentence itself is false has the same absurdity as saying a thought is blue. Even a declaration like "I am on time for work today" cannot possibly be true or false alone. The property of being late matched with a specific time condition allows one to ascertain whether the statement within the sentence was true or false. But the sentence by itself will forever just be a sentence. To clarify this distinction a little bit more, the sentence "I am not early or late for work today" has completely different components from the previous one. But the two are practically the same. They both contain the essence of the same declaration. All in all, the sentence "this sentence is false" lacks any substance to consider. It is merely a collection of words without any deep meaning. While going through each example, you hopefully noticed the illusionary veil that covers every paradox. Through the use of specific wording or implausible situations, paradoxes are built to challenge our preconceived beliefs. Most people confine paradoxes into a box beyond human comprehension. This very act is what enables that belief to persist. The only method of breaking paradoxes down is going outside conventional ways of thinking. Even if the resulting ideas seem foolish, they can point the way to truth. Do not be afraid to venture into the unknown in this pursuit, since you can always return to familiar shores. But before you leave, do you know whether the chicken or egg came first?